In this video, we're going to talk about local type inference, which is also known as implicitly typed local variables. And this introduces the var keyword to C#, which was included in the 3.0 version a couple years ago. And basically, it's an easy way to declare a variable without having to know the type up front. When we work with LINQ, many times it's not going to be very clear for a given LINQ query what LINQ is actually returning to us from that query. And in some cases, when you start projecting anonymous types from your LINQ queries, there is no pre-existing type, so you can't know it up front. And I'll explain what an anonymous type is later on in day 9. So the var keyword allows us to say, we really don't care what type it is. Let C# figure it out. And Microsoft suggests that you use the var keyword to make development easier. Now, some authors that I've read suggest that you should only use it as a temporary measure until you can figure out what the exact return type is. So one technique would be to set a breakpoint, run your application, hover over the value that's being returned from the LINQ query, grab that type, and replace var with that type. And I think that they're saying this because, you know, like me, they know that this leads to ambiguity, and ambiguity leads to laziness, and laziness leads to problems within your code. And I'm against laziness, but I do like convenience. So I'm going to side with Microsoft on this one. Whichever you decide is up to you. But the only thing to keep in mind is that the var keyword, it'll only work within the local scope of your given method. In other words, you can't return a reference for a given variable, a return value. You can't use it as a property. You can't use the var keyword outside of the scope of a local method, period. And we're going to demonstrate that just to prove it. All right, so let's walk through a few examples to see how all this works. You may have seen me actually accidentally use this once or twice in the series up to this point. But at any rate, I'm just going to copy and paste in some code. If you don't like me copying and pasting, just pause the video. Okay? Here we go. In this first example, you can see that I'm basically using the var keyword as a way of defining the data type for a variable called first. And then I'm initializing the value first equal to 7. Based on this initialization, var is going to infer that the type is assist.int32, or just int in C#. And we're going to verify that by grabbing the type from our variable and displaying it in a console window. So let's run our application, and you can see that indeed is what has happened. First variable is of type system.int32. Awesome. Okay. So once it's inferred, it can be used like any other type from that point on with no exceptions. So let me paste in a second little chunk of code here, and we'll comment this one out. All right, so here we go. Var second equals hello world. What do you think second's data type will be? It's going to be string, right? No question. So then we're going to muddy the waters a little bit by doing var third equals second. Will third understand that second is a string because second was defined by var here as a string? Well, let's run the application and find out. All right, so second variable is of type string, and the third variable is of type string. And that just, again, emphasizes that once the type is inferred, it can be used like any other type from that point on. If we had changed this out with string, it would work the exact same way. Let's run it. Exactly the same. Okay. Great. So that's pretty much it. I mean, we're going to get into some more complicated scenarios, but that's all you really need to know about local type inference. All right. So let's do this. Let's jump down here and let's show some things that you can't do with it. For example, I might be able to do this int my private field equals 1. Can we do that? Yeah, we can do that. Can I do this? Well, let's run the application and find out. Well, nope. The contextual keyword var may only appear within a local variable declaration. So we got slapped on the hands. Can't do that. All right. How about this? Public void my helper method var input param do stuff. Right there. Okay. Whoops, it wanted to change that out for me. Let's run this. Nope, can't do it. Contextual keyword var may only be used within a local variable declaration. What if I were to do this instead? Would it take that? Yep. Okay, so can't do that either. Can't use it as we're trying to define an input parameter for a method. How about this? We'll start out with the int version. And we'll just do this return 1. Okay, that should satisfy that little bug. All right, let's run the application. All right, so it compiles. You know, it's not going to do much. Let's change this to var. See if that works. Contextual keyword var may only appear within a local variable declaration. We got something else going on there too. Oh, namespace var cannot be found. Its etymology is the same. All right, so we can't use it to define fields. Can't use it as input parameters to methods. Can't use it as return value to methods. How about this? Well, here. And let's make a call to my helper method. All right, so doesn't look like there's anything wrong with this, right? We're not using it here as a return value or as an input parameter. Let's run the application. And we get another error. Why? Because implicitly typed local variables must be initialized. We're basically saying, yeah, we want C# to figure out what the data type is, but we're not going to give it any clues whatsoever. We have to do that or something like that. All right, that's how C# is able to implicitly infer the type. Okay, let's see something else we can't do easily. How about that? Let's run it. Can't assign null to an implicitly typed local variable. Why not? Null is like 0, right? No, null is not like 0. Null means we don't know what the value is. It could be anything. It's indeterminate. So again, it's no better than this situation. Here, we're not giving any clues to C# on what the value actually is to initialize this variable to, and therefore it can't infer the type. Okay, so then when is this helpful? I mean, it doesn't look like it does a whole lot for us just yet. But it does. So let me just paste in a little quick example here. Okay, so here's another example. What I want to do is go through an array of strings called states, and I'm going to initialize that array of strings with a bunch of states from the United States. Texas, Illinois, New York, Florida, Washington, Indiana, Oregon, and so on. Great. Then I'm going to only select out from that array of strings those values, so from S in states, where S starts with the letter I. And then once we get that, whatever it is it an array of strings? Maybe. Is it something else? Maybe. We don't know yet. We're going to let C# figure that part out because that's what it's good at. Then we're going to loop through each of these things. What is this? What state? Probably a string, but it might not be. We don't know yet. We'll find out when we step through the program. Var state in states, then print each one out. Okay. So let's see how this works. So I'm going to run it first. And notice here in this second section, states that start with the letter I, Illinois, Indiana, Idaho, and Iowa. Great. Now, let's do something fun. Let's set a breakpoint and run the application to find out exactly what's going to happen here. Now, if I hover over, this is clearly going to be an array of strings. Doesn't really indicate it very nicely there, but we know it is an array of strings. What we don't know is what this var iStates is going to be, so let's go ahead and step over that as well. And now I'm going to hover over iStates, and I see that iStates is what? Okay, it's not all that obvious here because it hasn't been executed yet. And that's a feature of link that that we're going to talk about soon. But you know, for the purposes of this application, it's going to be of type system.link.enumerable.where_array iterator of type string. Huh. Well, that's kind of crazy. So now, what are we going to do here? What is type state? Again, it's not completely obvious. We know what the value is, but how do we know what the type is? We could do something like this. Looks like it's going to be of type system.string. Okay. Well, let's do the same thing here because I'm not completely convinced that we still know the type of that iStates. Oh yeah, it is a, you know, system.link.enumerable where array iterator thingy. I would have thought it was of IEnumerable of type string. See, so there you go. What are you going to do? Type in that whole thing, or are you going to type in, you know, var instead? So I think you see where I'm going with this. Hopefully it makes sense of why you would even want to use the var keyword instead of when you return values back from a link query, why you'd want to go through all of the headache of trying to figure out what the type is that link is actually returning. Okay, so that wraps up and hopefully gives a thorough discussion to the topic of local type inference, or rather local implicitly typed local variables, whichever way that you may hear it in other writings. But again, a crucial building block as we begin to learn more about link, and we use it with linked entities and linked XML. Okay, great. We'll see you in the next video. Thank you.